This time on Captain Castle's laboratory, we're going to be working on the treetop tender, one of the train cars. I don't know the voltage that goes into this. I was just told it doesn't work. So we're going to have to figure it out by opening up and looking at the components and getting some basic ideas. But looking at it, just doing a general once around, this is a light. And that's opaque, and it looks like there's a light bulb inside the star. So I'm assuming those light up. This guy is on a moving platform. This is on a spring hinge. This side is not. This side is fake. The presents might light up. I don't know anything about this other than I was told it doesn't work. And if I can open it up and see why. So here we are. It gets power from here. I'm assuming this plugs into the car in front of it, and there's an output port right here, which is a flat Molex style connector with a whole bunch of pins, and this one on the front has 4 pins, and it's a different style connector. So I could have probably Googled it, maybe got some info on it, but I didn't. It's got some contacts that rub along the tracks on the bottom, right here and here. There they are. This bottom section looks like it would pop off. It doesn't. So I'm going to unscrew this. It looks like there's only 4 screws to hold that on. So turn on the screwdriver and let's give it a whirl. Okay, also on the bottom, there's the circuit board or the transfer. You can see the ribbon cable for that Molex style connector. Those are the only screws I see, and now we can lift her up. And we got lots of tight cables. We got a light in the back. Looks like with this guy pivots and this light, something's connected over here that I can't quite see. Got a working flashlight? No. I have all these flashlights and I keep forgetting to put batteries in. I know one of them's got to work. That one does. So it looks like what's holding it is the cable for this. So I don't know if I can get some slack in here. It looks like it should move. I see one more screw. I don't know if that's going to help. I don't even know how to get to it. Well, I got to it. That helps alleviate the stress. So now I can pull him off. We can now get access to, there's a really big circuit board in here. Right there. Well, looks like we got a broken component on here. 5 watt, 1 ohm resistance. It looks like a big block resistor. Looks to be broke. Got a big relay, looks okay. Ribbon cable's intact. Alright, well, let's get to the next layer. So this also separates, again, there are 4 screws inside. Alright, so those 4 screws are unscrewed. Let's use some needle nose here to try and grab them. And the 4 screw fell inside where this top separates. Fell inside here. There's the door. Here's a better look at that circuit board, which does not look good. Okay, so the circuit board has an obvious burn. Right where that resistor is, and there's some diodes too. Looks like we got some smoke components. I'll try and zoom in here in a second. I'd like to know where that screw went. There's 2 screws that hold in the circuit board. Take those out and see if we can free up some room. The 2 wires that go here go up to the light on the star, so I am right, this is a lit. Probably should have Googled this thing to see what it looks like, so I have an idea. I'm assuming this is the main board, since it has a speaker in here. So this probably is what controls the entire train. How they put this thing together with, they must have assembled it and then soldered the wires on. But I'm going to put on some magnifiers and we're going to take a closer look at the blown up diode, which blew up into the resistor. It's a block, it's a high temperature resistor. It got hot. The resistor it might still be okay. It can handle a lot of heat. It's a high temp ceramic resistor. I used to use them on cars. Boy, I wish there was a way to disconnect this stuff, but we'll have to make do with what we got. So let me show you what's going on with this train. Yeah, that's probably about center, so I can zoom down. And focus. Okay, so here's the circuit board, and if you look at it, let me get a pointer here. Here's a pointer. You see this is all discolored right in here. You see how this is a shinier green and this is kind of a dark green? That's actually a burn. And then, if I can get this thing to move, I'm going to have to flip the whole thing over, so bear with me. It's not going to be the easiest because of these wires. I don't want to cut them. I was asked if it's not salvageable not to cut them, so I'm not going to cut them. All right, flashlight. All right, and if you look right there, you'll see where the board burned. That big fat black with silver band component is called a diode, and the one next to it's a diode as well. This one's just a higher power diode, meaning it can handle more current. That's why it's so much fatter and thicker. This right here is a resistor right there. So the side of this resistor is covered on what melted from the diode. And I'm wondering if it took out the capacitor too. I have no idea. But the point is something in here let go. Something failed, something shorted, or else, because this diode is rather large. This is a high power diode, kind of like you'd find in an amplifier. I mean, these are standard diodes. You can see this one's smaller than this one, and this one is technically smaller than that one, which is hard to see on camera, but this one's about half the size of this one. This one's maybe a third the size of that one. And give you a reference, these are half-watt resistors. That's a 5-watt resistor. See the difference in size? Components are very important to be scaled for power and heat. That means they get really hot. That can handle a lot of heat. But this resistor is also cockeyed, and I'm going to try and hold the board. It's not attached. It's blown itself free from the board. It still might be good. That's what I was saying. Hey, that's what I was trying to do, is separate these. There's some discolorationing, right? Discolorationing. Gotta make new words now. Discoloration on the wire from the heat. The wire was all yellow, then there's a burn, which is kind of a brownish orange, and it continues because this wire was under the lip. And you can kind of see inside the resistor. It's hollowed. And you can see the wire comes down. This probably was flush, and it got so hot it started to pull away because it's upside down, gravity. And then we come back up to the bottom of the board, which is the top in this case. And then there's your discoloration right here. So the problem I have is not knowing exactly what this thing's supposed to do, because it didn't get the rest of the cars, because apparently the person that owns this didn't want me to get the rest of the stuff. They just want me to diagnose it, so that's all I'm doing, to see if it is repairable. Without the rest of it, I can't attempt to repair it. But you can see the burn. This thing got hot all the way around. So these small discrete components right here, I would probably say that one and that one, are potentially damaged as well. Heat. The electrical components generate heat and they don't like heat. This is the capacitor. You can see it's a 220 microfarad to 16 volt. So I'm assuming this train car is 12 volts or less, because you always want to be no more than like 10% within tolerance. So 10% would be 14.4 volts below the 16. Most people run a 16 on a 12 volt circuit. So that way you're only 3/4 of the way there. And that's a 16 too, you can see. So I'm assuming this is probably still good, but because of the proximity to the burn right there, I would replace this, and then we'd have to test these. But I need a power supply that plugs into this 4-port connector, because I don't know which goes where. I don't know if all 4 are used or only 2 are used. Let's see. All 4 are used. Here's the wires that come out of that connector. We got a green and a yellow here, and a white and a cream. It's kind of a coral color. Goes over here and here. So I really need the rest of this train. But I diagnosed it. It has a burnt board, and at least 1 component's fried, possibly 2. I'm going to go with most likely close to 5. Resistor, capacitor, diode, transistor, and this other thing right over here, right there, is also a resistor. That's what the R stands for, the R16. And the Q stands for transistor. So, I'm going to zoom back out now. There we go. Focus. There we go. All right. So, on this Treetop Tender car, it looks like the issues is going to be something shorted and blew the components up on the board. Whether it be caused by age, moisture, a bug got in here, like an ant. Anything that's conductive can blow something. And if you go with age, nothing lasts forever. This diode right here that popped, it could have just been worn down over time because it's a big diode. The heat finally got to it and it fatigued and failed. Any number of things can cause it. But I need the other end of this to touch it with a voltmeter to find out where I'm losing power. Before I would do that, though, I would remove this diode, which is most likely bad, and this resistor, and replace it first. But all I was asked to do is diagnose this and give them a, do you think it's repairable report. There's some garbage in here, some foam from the packing. So that's what I'm going to do. I'm going to let them know that it's got a burnt circuit board. You got a couple of blown components, at least 2 I would go with at the moment, or probably 5, and I'm going to give it back to them and see what they want to do from that point on. I don't know what about this train it is. They want to keep it fully intact, so if it doesn't work, it's not a parts train, they're going to use it in a display. I don't know how. They'll probably maybe just backlight it. But it's part of a very large Christmas display here in Scottsdale, Arizona. A lot of people may know of it. It's the Burkett House, and this is part of their display. So I'm not going to go any further. I'm just going to reassemble it once I get that screw to, oh, there it is, that screw out, finally fell out. And we're going to get this back to him and give him a diagnosis as far as what's going on. So not a repair video, just a diagnose video. So if you own this full train set and you have it just stop, check this car here and check your circuit board. It might be your cause. I don't know what the rest of the train cars look like. I don't know if the rest of the train cars have circuit boards in them. They might have distribution boards. I don't know if they have full circuit boards. I'm not familiar with this train car or this train set, but... And apparently these contacts on the bottom, not sure what they do, but this yellow and blue wire, the one that's got a burn on it, do come down and connect to these 2 sets of trucks. So they do something. I just don't know what they do. But they do send a signal up to this board. So I'm not sure if that's how it gets additional power from the tracks, or if it reads the tracks and the tracks have a sensor or magnet in them that makes it change what it does. I'm not sure at all. If you have this piece, I'm sure you know what they do, but I don't. So this is where we're gonna stop. I appreciate you watching how I diagnose things, how I search for things, what I look for, and what you should look for if you have something that's not working right. Most of the time on a bad circuit board, you don't see the component that's failed unless it burns or explodes, like this one did, where it burned. Sometimes components fail internally and you don't see anything, and then you have to actually test them with a meter. That's where you need a multimeter. So for this one, we're going to call it done. I'm just going to reassemble it. Reassembly is just the reverse of disassembly. I'm going to put it back into its bag I got it in, wrap it back in its plastic, and let them know that circuit board's burnt. And I need the rest of the train, or at least the front of the train that sends the signal to this, so I can diagnose it further. If I get it back, we'll continue this as a in addition to, or part 2 of this. If I don't get it back, then now you know how to take it apart and how to look at it yourself. And if you have a burned out LED, there's an LED down here you can replace. You got some LEDs on the top of the board. Right here, there's 4 of them in the corners, basically, that are easy to replace. And yes, I was right. They do go inside of the present, drum, present, present. And then you have a red and yellow wire that goes up to light on the tree. And then you do have a set of wires that go in here to replace this bulb or LED. If this one fails, because it's in its own housing, this housing has a seam and I can see the glue. So if you take a thin spudger, you can pop that housing open. It's probably glued. And then replace the LED. And then put a dab, and I mean the smallest dab of super glue, and push it back together. And the reason I say the smallest dab is if it burns out again, you want to be able to pop it open. If you paint this entire seam top and bottom with the super glue, you're never going to open it. You could use hot glue too, but hot glue is usually thicker. So I would only put a dab, maybe a dab in the front where the lens is, and a dab in the back here where it goes around the arm or pole for the light itself. So if it's something basic like that, it's easy to get to. If your speaker blows, there's your speaker. Your speaker is a 8 ohm half watt, which is standard in the hobbies. Pretty much most of all Lemax and Department 56 that have noise, those are the speakers they use. They come in different diameters. You can find them online. They're just basic hobby speakers. You can get them on Amazon or eBay. If you have a local hobby shop that still exists, you can probably even get them there. If you have a Radio Shack, they are kind of sort of making a comeback. There's one or two here I've come across in Arizona, so it is possible that you might have one near you. But it's a basic speaker. A lot of the components in here are basic. Technically, a lot of this should be repairable, but we're going to leave it here. So, thanks for watching. Till the next one. See you then.